So now we're ready to perform these symbolic operations. Again, I don't know if I've already said it or not. In the homework, unless you're told otherwise, assume that the tail is 0, 0. Okay, and the reason I say that is most books will do that. So if it shouldn't be an issue actually when you're just adding these things together, but a lot of books will think of it that way, and it's a little bit restrictive because in physics you like to put copies of vectors in different places, like you saw when we added geometrically. But okay, so in this example we're going to let v equal the vector 2, 3 in component form, and u equal the vector -3, -4. Perform the following operations: v plus u. So what's v? V is 2, 3, and u is -3, -4. And so we're going to add these guys together. So what do we get? Yeah, and just for completeness in the notes, I'm gonna write for the first component 2 plus -3. But obviously you can do that in your head, and you don't have to show that work if you don't want to. And then what's the other one? 3 plus -4, 3 minus 4. If you do want to show the work, you could just write it as 3 minus 4. So what does that turn out to be? -1, -1? Okay? Yeah, I just made up the example. I didn't mean for them to both be the same. They won't always be the same. Okay, now v minus u. Okay, so let me take a copy of what I just wrote down. So in the last problem, this is what I wrote down, so this first guy, 2, 3, was v, and the second guy, -3, -4, was u. But what am I going to change here? Just the plus to a minus. Now, you can define subtraction using addition, right? So what does this become if you want to write it using addition and in component form before you combine it? It'd be plus what? Well, here, you could think of it like this: plus a scalar of -1 times that vector, -3, -4, right? And so if you do that, these guys change, the signs change in both of these. They both were negative, so they change to positive. Does that make sense? Okay, easy enough. You add them together, what do you get? 5 and 7. That's it. You thought it was going to be harder than that, didn't you? Okay, so I want to remind you, u was -3, -4. So 2u, in part C we're finding 2u, which would be 2 times -3, -4. Okay, so what's that? Yeah, so maybe for variety we should do something other than 2, right? What do you want to do? No, I don't want to do that. How about -5? So what would what's the scalar? This is scalar multiplication. What's the scalar? -5. So u was -3, -4, so we're going to multiply that times -5, and what would the result be? 15, 20. Okay. Questions on that? That's it. Well, here it gets a little bit interesting, at least. We're combining operations in this one. Okay, think back to order of operations. Do you think that's going to change much? So let me ask you this. Are we going to scalar multiply first or add first? Scalar multiply first. So let's write down what it is. I think u was -3, -4. So when you see 2u plus 3v, it means 2 times u, which was -3, -4, plus 3, a scalar of 3, times v, which was 2, 3. Do the scalar multiplication first. What is 2 times -3, -4? What vector is that? -6, -8, plus, what's this vector? 6, 9. Now you add component-wise, add corresponding components. What do you get? 0, 1. Any questions?